Hi guys, today we're going to be solving systems of 3 linear equations using the calculator. You've done the hard work and learned how to do it by hand, and now I'm going to show you how to use matrices to solve it in the calculator. So the first thing you want to do before you put it in your calculator is you want to organize your 3 equations into standard form. So be sure you check to make sure your x's, y's, z's, and your constants are lined up like this before you set up your matrices. So if you have to rearrange it, do that first. Your next thing you're going to do is you're going to pull out all of the coefficients. So the coefficients here is going to be 1, 3, 5, 7. That's my first row. 2, 4, 6, 8, second row, and then the coefficients. This is called my matrix, and that's what we're going to put into the calculator. Okay, look for the matrix button on your calculator. Let's see, where can I put my calculator that you can see it? I'll put it here, and then we'll follow along with the directions. Okay, so you are going to go to, you can see the matrix button is right there in blue, okay? So you're going to hit second matrix and over to edit. This tells you how many blanks you would like to have, okay? So I have 3 rows and 4 columns. So at the top, I'm going to enter 3 by 4. That's going to give me the appropriate number of blanks. There we go. Okay, so now I'm going to enter in my numbers. 1. Each time you want to go to the next blank, just hit enter, and then it'll go across. 3, 5, 7. 2, 4, 6, 8, 3, 9, 7, 12. Okay, once you have them entered in, I'm on this step right here of the notes. Now we're going to go back to the home screen. Second quit, that's this button right here. I should be back on my regular home screen. Now, in order to do the calculation, you're going to go to second matrix again, go to math, scroll over to the right one, and then you're looking down, all the way down until it says RREF. Notice I did not choose option A, that's option B, RREF. That's what it says right here on your notes. That stands for reduced row echelon form, which you don't need to know that, but that's the operation we're doing to solve the matrix. If you ever do linear programming or algebra, whenever you get to college, you'll get to do reduced row echelon form. But we're going to allow the calculator to do the hard work for us today. So whenever you hit that, your screen will look like this. Then we want to do reduced row echelon form on the matrix that we just entered in, which is in matrix A. So you're going to hit second matrix again. There's our data in A. So hit enter on A. Then this is our solution. Notice for my solution these diagonal ones. This means that it found one solution for the x, one for the y, and one for the z. The order that you put them in, like the x, y, z, is the order that they're going to come out. So my solution here is, try and move it so that y'all can see, okay? This number is going to be my x, this is going to be y, and this is going to be z. Okay? And some of your answers today are not going to be nice whole numbers. Since you have the calculator, we have the flexibility to do some more interesting problems that involve money or different things that you may get a decimal for. Okay, so now that you know the steps, let's practice some problems. So today you are going to do 2 things. You need to be able to set up the equation from the words, translate it into a matrix, and then find the solutions by plugging it into your calculator. Okay, scenario 1. Amy, Leslie, and Kara are siblings. Amy is the oldest and Kara is the youngest. The sum of the ages of the 3 siblings is 23. Amy's age is 4 more than twice Kara's age. The difference between Leslie and Kara's age is 3 years. The question here is, we're trying to figure out how old each of them are, and that sentence would be helpful if it was in there. We're trying to find how old is each sibling. Okay. So whenever you're whatever your question is, that helps you figure out what the variables are. So I want to figure out how old Amy is. That's going to be my first variable. Kara. And Leslie's my third one. Okay, now we're going to write our equations by reading it again. They're siblings. That doesn't give me an equation. Amy is the oldest and Kara is the youngest. Good information, but I can't really write an equation from that. The sum of the ages of the three siblings is 23. I can write an equation about that. So it says the sum, so that means Amy plus Kara plus Leslie is always means equals 23. All right, we have one. Amy's age is, remember is equals 4 more than twice Kara's age. Okay, so I'm going to do twice Kara's age and add 4 to that. The difference between Leslie and Kara's age is 3 years. So Leslie minus Kara is 3 years. Okay, in order to solve an equation that has 3 variables, you have to have 3 equations, otherwise it's not solvable. Okay, so we need to come up with 3 equations if we have 3 different variables. So we have our 3 equations. Now we want to rearrange it so we can put it into our matrices. So when I look at my equations here, this one is organized nicely because I have all my variables on the left and my constant on the right. So I'm going to keep this one as is. Now I want to line this one up underneath it. Oh, that should be an equal, sorry. Okay, so I'm going to leave A on this side of the equal sign, but I would like this to be on the other side of the equal sign. That way it's right under here. So this is going to be a negative 2C when I subtract it over here, and I'm going to leave my constant over there. This one I'm just going to line up. Let's see, L is positive, C is negative, and the 3 is over here. So all your variables on the left, constants on the right. That way we can set up our matrix C. So I'm going to pull out all the coefficients. That's 1, 1, 1, and my constant is 23. A is 1, negative 2 for C. Notice I have no L, so I need to make sure and put a 0 in there when I'm missing a variable. There's 4. No A on this equation. A negative 1 here for the C, 1 for the L, and 3 for the 1, for the last constant. Okay, we're ready to put it into our calculator. So go to second matrix. We are going to edit our matrix. You can go ahead and just type over this one. So I want to keep a 3 by 4 again. And I'm going to type in my new data. I'm just going to type right over it. Be super careful typing in, because if you make one wrong entry, it's going to make the whole thing wrong. So just be careful about that. I'm also keeping in mind, since this is ages, I'm expecting not negative numbers. So sometimes you can catch your mistake by looking at our answer and being like, ooh, I got a negative answer, I can't have a negative age. Something must have been wrong. Okay, second matrix, here's how you do the math. Go to math, and then I'm looking for RREF. That's option B. That's the option we're looking for every time, RREF. And then I'm going to grab matrix A. Once it says that, it's ready to do the calculations. Sorry, you can't see it. There. It should say that. You're ready to do the calculations. Notice my diagonal 1 says it's found the solution. My first variable is 12, 4, and 7. So remember, they're going to come out in the same order that we put them in. And the order we put it in was A, C, L. So that means my A, which is Amy's age, she's 12. C is what I put in next. That's this one. She's 4 years old. And Leslie is 7 years old. Whenever we're doing a real-world problem, it's also always a good idea to go back and make sure our answers make sense. For example, we know the sum of the 3 sisters is 23, so those add up to 23. That does make sense. Amy is 4 more than twice Kara's age, Okay, here's Kara, 4 more than twice. So if I double it, that's 8, and 4 more is 12, so that works out. The difference between Leslie and Kara's age is 3 years. So Leslie minus Kara is 3. So it checks out. And so you have the opportunity to really check your answer and make sure that it's a good one. Okay, pause the video here. I would like you to read this equation and define your variables and set up your system. And then you can unpause to see if we agree with our setup. Did you get it? So what you should have gotten is that we are trying to find the cost of the hamburgers, the french fries, and the sodas. That's what we're trying to find in this problem. So that's going to be our 3 variables. And if you call them X, Y, Z, that's totally fine. It doesn't matter what letters you use, as long as you know what they represent. So when you get your answer, you know what your solution is. So for each group, you should have written an equation. They kind of laid it out nicely for you in this problem because it was just 8 hamburgers, 6 fries, 6 large sodas for a total of 2610, which is also nice because your matrices is already organized as well. All you have to do is pull out the coefficients because this one was pretty much done for you. Okay? So then you should be putting it into your matrix, into edit, and again you can just type over those numbers. And then to do the math again, you do matrix, math, RREF on matrix A, because that's where we put our data in. Uh-oh, I did something wrong. I can already tell I did something wrong because this should be dollar amounts, right? So if I get a weird answer like this and this does not look like money, then I did something wrong. So let's see what I did wrong. I probably typed something in, which happens all the time. 866, 2610, 1068, 3160, 224, 1095. I'm going to pause the video and see if I can find my mistake. Hold on just a second. Okay, you probably saw my mistake before I did. This was supposed to be a 3, not a 2. Okay, so I retyped it in and did the math here, the RE reduced row echelon form on A. And hamburgers cost $1.95, French fries cost 95 cents, and sodas cost 80 cents. Okay, try it again, pause the video, and let's see if you can set the last problem up. This word problem is a little bit harder. Okay, let's see how you did. Your first equation, well, first of all, let's talk about our variables. Our variables are the pounds of chicken, pounds of sausage, and pounds of rice. So I labeled mine C, S, and R, okay? Your first equation should be about the money. So it was $6 per pound of chicken, plus $3 per pound of sausage, plus $1 per pound of rice, for a total of $42. Your second equation should be about the total pounds of food that she bought. So the pounds of chicken, sausage, and rice all add up to 13.5 pounds because she bought total 13.5 pounds of food. The last equation is the trickiest one. She buys twice as much rice as sausage. So when you think about this, she's got twice as much rice. So she has more rice, right? Let's say she just bought 1 pound of sausage. How much rice is that? Well, she has twice as much rice, so that's 2. Or let's say she got 2 pounds of sausage. Twice as much rice would mean there's 4 pounds of rice, right? So let's write an equation that represents this. These numbers make sense. What would make that? Well, if I was going to write this equation, I need to times the sausage by 2 in order for it to equal the rice. 2 times this would be this. 2 times the 2 would give me this. So sometimes it's helpful to plug in some numbers to make sure that you're getting the right equation, because this one is a little bit tricky. So be careful about that one. Okay, you should be good to go from here. We're going to arrange our equation. All of these are perfectly arranged except for this last one. I want to make sure and put a negative 2s, r equals 0, whenever I plug it into my matrices. So what my matrix is going to look like is 6, 3, 1, 42, 1, 1, 1, and 13.5, 0 for chicken, -2 for sausage, 1 for rice, and 0 for my constant. Okay, go ahead and type it